Ladies and gentlemen, welcome to this episode of my tutorial video channel. In this video, I will discuss what is linear programming problem and how to solve a simple linear programming problem. The phrase linear programming consists of two parts, linear and programming. Linear means the relationship between two variables can be represented by a straight line. This means two variables are linearly related to each other. And the term programming means planning or making decisions or solving problems in a systematic way. Mathematically, linear programming refers to formulation and solution of a problem where some linear objective function has to be optimized. It might be maximization or minimization. Whatever it may be, the linear objective function has to be optimized subject to some linear constraints, that is subject to a set of linear constraints, and at least one of those linear constraints must be expressed as inequality. So, linear programming problem, or in short LPP, has two parts. One is objective function and the other is subjective functions. Now, we shall solve one problem where we have one objective function and three constraints, linear constraints. The objective function is maximize z equals to 3x plus 4y. Subject to, that is the subjective factors or constraints are 4x plus 2y must be less than equal to 80, 2x plus 5y is less than equal to 180, and x and y is greater than equal to 0. When you would go on solving this kind of problems, start with the constraints or subjective factors. Let this be equation 1. And let this be equation 2. We start with equation 1. We put x equals to 0 in equation 1. Putting x equals to 0 in the equation, what do we get? 4 into 0 plus 2y is less than equal to 80. You can write this also like 4 into 0 plus 2 into y equals to 80. While solving the problem, for all practical purposes, you can consider this 4 into 0 plus 2y is equal to 80. Therefore, 2y equals to 80 or y equals to 80 by 2 equals to 40. So we get one set of values, that is x equals to 0, y equals to 40. Now we shall put y equals to 0 in equation number 1. So putting y equals to 0 in the equation, that is in equation 1, what we get? 4 into x plus 2y is equal to 80. Four into x plus 2 into 0 equals to 80. We have put 0 in place of y. Therefore, 4x equals to 80. Okay, we have put y equals to 0 in 4x plus 2y is equal to 80. So 4x plus 2 into 0 equals to 80. Therefore, 4x equals to 80 or x equals to 80 by 4 equals to 20. Okay, so we get another set of values, that is x equals to 20 and y equals to 0. Let us draw the straight line by these coordinates. This is x-axis, this is y-axis. 10, 20, 30, 40, 50, 60, 70, 80, 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. I am not drawing the diagram to the scale. I am only making estimates. These are all approximations. You also need not have to draw a diagram on a graph paper, because you can solve it graphically too. In fact, we are solving it graphically with a little bit of algebra. So the points are 0, 0, 40 and 20, 0. So first point is 0, x is 0, y is 40, 10, 20, 30, 40. So this is the point, this is the coordinate. This is 0, 40. Okay. Next, x is 20, y is 0. 10, 20 and y is 0. So this is the point, this is the coordinate. 20, 0. Now we shall join these 2 points with a straight line. So this is the equation of this straight line is 4x plus 2y, 4x plus 2y equals to 80. Okay. Now come to equation number 2. Putting x equals to 0, we shall follow the same procedure as we have done in case of equation number 1. So putting x equals to 0 in equation number 2, we get 2 into 0 plus 5 into y equals to 180. Therefore 5y equals to 180, or y equals to 180 by 5, that is 36. So we get one set of values, that is x equals to 0, y equals to 36. Now we shall put y equals to 0 in equation 2. So putting y equals to 0, what we get? 2x plus 5 into 0 equals to 180. Therefore 2x equals to 180. Therefore, or x equals to 180 by 2 equals to 90. So we get another set of values. X equals to 90, y equals to 0. So here we shall put the coordinates. First one is x 0, y 36. So it will be somewhere here. This is 0, 36. Next one is x 90, y 0. So 10, 20, 30, 40, 50, 60, 70, 80, 90. This is 90. This is 90, 0. So we shall join these points by a straight line. Okay. Yeah. Like this. So equation of this straight line is 2x plus 5y is equal to 180. Now this straight line and this straight line intersect at this point. Let this point be A. Now we have found an enclosed area, that is this shaded area. Right? This shaded area is called visible solution area or space. Okay. So we have got an enclosed area with 4 corners. This one, first, second, third and fourth. We need not consider this coordinate because 0, 0 means profit is 0. We shall only consider the coordinates of these 3 points. This point, A, and this point. So coordinates of this point and this point are known. So you have to find out the coordinate of this point, point A. How? By simply solving these 2 constraints, that is simply solving 2 quadratic equations. So here you write coordinates of point A. Coordinates of point A. What are the equations? The constraints, linear constraints, 4x plus 2y is equal to 80 and 2x plus 5y equals to 180. This is equation 1 and this is equation 2. 4x plus 2y is equal to 80 and 2x plus 5y equals to 180. Multiply equation 2 by 2. Four x plus 10y equals to 360. Multiplying 2 by 2. Multiply equation 2 by 2. We have got 2x into 2 4x, 5y into 2 10y and 180 into 2 360. Say this is equation 3. Now we subtract equation 3 from equation 1. Subtracting equation 3 from equation 1. What do we get? 4x go away, remains 2x plus 2x plus 2y minus 10y, that is minus 8y equals to 360 minus 180 is 180. Right? 4x plus 2y equals to 80 and 4x plus 10y equal to 360. We subtract equation 3 from equation 2, we get 4x minus plus 4x minus 4x go away, plus 2y minus 10y, so minus 8y, and plus 80 minus 360, that is 360 minus 80, that is 280. Therefore, y equals to 280 divided by 8. Let us see what we get. We get 35. So y equals to 35. Now I put the value of y In equation 2, putting y is 35 in equation 2, what do we get? 2x plus 5 into 35 equals to 180. Yeah. Therefore, 2x plus 175 equals to 180. Therefore, 2x equals to 180 minus 175, that is 5. Therefore, x equals to 5 by 2 equals to 2.5. So, the coordinate is x equals to 2.5, y equals to 30. The coordinate of A. This is 2.5, 30. Sorry, 35. 2.5 and 35. What's 35? Yeah. Now we would form a table consisting of 3 columns: x, y, and z. First we put this coordinate 0, 36. Then A 2.5, 35. Then this point 20, 0. What is the objective function? 3x plus 4y. So here you get 3 into 0 plus 4 into 36. That is 0 plus that is 144. Here the value is 3 into 2.5 plus 4 into 35 equals to 7.5 plus 140, that is 147.5. This is 7.5. And the value of z here is 3 into 20 plus 4 into 0 equals to 60 plus 0 equals to 60. So you look at the highest value, the maximum value, that is 147.5. This is the maximum value of z. So the answer is max z equals to 147.50. Complete. Okay. So this is the way you should solve this kind of simple linear programming problems. In my next video, that is on part 2, we will see how to formulate a linear programming problem and then how to solve that. Here I have only discussed what is meant by the linear programming problem and how can you hit the problem. We have taken one example. There is one objective function, maximize z equals to 3x plus 4y. You have to maximize z subject to some linear constraints, a set of linear constraints. This is the set of linear constraints. Number 1, 4x plus 2y is less than equal to 80. Number 2, 2x plus 5y is less than equal to 180. And number 3, x and y must be greater than equal to 0. We have started with the constraints, the subjective functions. First, we have taken the equation number 1. That is this equation. This is equation 1 and this is equation 2. And we have put the value of x as 0 in equation 1 and found out the value of y. So we get one set of value, x equals to 0 and y equals to 40. Then we put y equals to 0 in the same equation and calculate the value of x as 20. So we get another set of values as 20, 0. Now we plot these two coordinates in the graph paper. Although I have not put the points on the graph paper, I have only made approximations. You also do it in the same way as I am doing, as ultimately you will be solving it algebraically. And we have joined these 2 points, that is 0, 40, 20, 0, 0, 40 and 20, 0, 0, 40 and 20, 0. And this is 4x plus 2y is equal to 1 is equal to 80 is the equation of this straight line. Then come to equation 2, that is 2x plus 5y is less than equal to 180. We do the same process here as we have done in case of equation number 1. First we have put the value of x equals to 0 and calculated y equals 36. So one set is x equals to 0 and y equals to 36. And then we have put y equals to 0 in the same equation and we calculated x as 90. So we have got another set of values, x equals to 90 and y equals to 0. And we plot those coordinates 0, 36 this point and 90, 0 this point. And we have joined these points to a straight line. So 2x plus 5y equals to 180 is the equation of this straight line. These two straight lines intersect at point A. So we have found out an enclosed area consisting of 4 corners, this corner, this corner, this corner and this corner. This is called feasible solution area or feasible solution space. We have to calculate the coordinate of the point of intersection, that is point A. We have done that by solving these two constraints, that is two quadratic equations, that is 4x plus 2y equals to 80 and 2x plus 5y equals to 180. We have solved these two equations algebraically, these two quadratic equations, and we calculated the value of x and y as 2.5 and 35. So the coordinate of A is 2.5 and 35. Then we have constructed a table consisting of 3 columns to find out the values, different values of z by putting these values. First we put 0, x as 0 and y as 36. So we get z equals to 144. Putting x equals to 0 and y equals to 36 in this objective function 3x plus 4y, max z is 3x plus 4y. So 3 into 0 plus 4 into 36 equals to 144. Then we put the coordinate of A, that is 2.5 and 35. We put the values in the objective function. So 3 into 2.5 plus 4 into 35. This gives us 147.5. And finally, we put this value 20, 0. This value, the coordinate of this point 20, 0 in the objective function. So 3 into 20 plus 4 into 0 equals to 60 plus 0 is 60. So the maximum value of Z is 147.5. So the answer is max Z equals to 147.5. Yeah, that's it. This is all about this video. I believe this is well understood by you. Still, should you have any doubt in your mind, if you have any query, please don't hesitate to let me know through the comment section. I shall be very happy to answer to all your relevant queries. If you think this video is beneficial for you, it is useful, please do share the video with your friends, brothers, sisters and colleagues so that they can also be benefited by watching this video. And finally, thank you very much for your precious time. Stay well and goodbye.